Okay, so now we are moving, we had come into the last part of urine formation, right? Which is the process of secretion. Okay, so what is secretion? Okay, so secretion occurs at proximal and distal tubule. Okay, so definition of secretion is the transport of molecule across the membrane of blood capillary and renal tubule into the filtrate. So in other words, you can see, look at the arrow. If the arrow is from surrounding interstitial fluid or surrounding blood capillary into the filtrate, right, that is the process of secretion. But if you can see, the arrow is from the filtrate out into the surrounding tissue or surrounding capillary. So this process is actually referring to reabsorption. Okay, right? So again, as you can see, this arrow showing you movement of molecule or solutes or ions from the blood capillary, okay, or from the surrounding tissue into the filtrate, within the excretory tubule, right? So what is the purpose of the secretion? The purpose is to enable the tubule, right, to excrete molecule that not originally present in the glomerular filtrate. Untuk membenarkan, alright, the tubule, the excretory tubule kita, to excrete molecule yang sebenarnya tak termasuk dalam barang-barang ataupun bahan-bahan yang tertapis. Contoh, drugs, dadah. So dadah bila kita ambil, dia akan masuk dalam darah. It will circulate in our blood capillary. So daripada darah, it will be secreted. Alright, it will be secreted into the tubule. Alright, and it will travel along the filtrate and end up, it will be excrete in the urine. That's why drug can be detected in the urine. So that is because of the process, the secretion process. Okay, right. It is not originally present in the glomerular filtrate, but it came from the blood. It maybe came from the, usually from the blood as it traveled along the blood circulatory system. Okay, right. Okay, next, let's see what happened here. Right, so we have the secretion process that happened in proximal and distal tubule. So the same thing, you have to take note on the mode of transportation of the solutes or the molecule. So here at proximal tubule, you can see there is an active secretion of hydrogen ion, right? And passive secretion of ammonia at proximal tubule. And at distal tubule, you have active secretion of potassium and also hydrogen ion. All right, okay. So what is the purpose, okay, of secretion of hydrogen ion and potassium ion? So I did mention just now, you can see the secretion of hydrogen ion from the blood, for example, into the filtrate is actually helping in regulating the pH of blood. So if our blood pH is too acidic, so hydrogen ion from the blood, all right, will be secreted into the tubule, right, so that the blood pH can be increased back to the set point. Okay, so similarly to potassium ion, so the secretion of potassium ion is to control the impulse transmission. All right, okay. So some ion like potassium ion, hydrogen ion, ammonium ion, drugs, toxin after processed by the liver will be passed from the peritubular capillary, right? Remember, peritubular capillary is capillary surrounding distal and proximal tubule, then into the interstitial fluid, then actively secreted into the proximal tubule. All right, okay, as well as the distal tubule. So look back the picture. Right, so you have what happened here at the distal tubule and the secretion of secretion that happen at the proximal tubule. Okay, right. Okay, so finish with that part. Okay, now we go to the hormonal regulation of body fluid, right? By antidiuretic hormone, ADH, and also renin-angiotensin-aldosterone system, RAAS. Okay, right. Okay, regulation of body fluid by hormone, right? So we have two things over here. First, please focus on the regulation of blood osmolarity, kepekatan darah. So blood osmolarity will be controlled by or regulated by ADH, antidiuretic hormone, that is secreted from our pituitary gland. So which pituitary? Anterior or posterior? Please check. All right, okay. Second one is regulation of blood pressure and also blood volume. So if the question asks you or give you some clue, so please read the statement carefully. If it does involve osmolarity, meaning it is referring to ADH. But if it refers to, or what you call it? Refers to the blood pressure and the blood volume, it is related to renin-angiotensin-aldosterone system, or we call as RAAS. Okay, right. Okay, now let's start with the regulation by ADH, or we call as vasopressin. Okay, now, so this is our hypothalamus, right? So this is our pituitary gland, right? That secrete ADH. Okay, now let's see a situation over here. The situation is okay, thirsty. So when you feel thirst, that is actually what you call it? Reflecting that your blood osmolarity is increased. Right? Kita haus. Kenapa kita haus? Kita minum, kenapa kita, bila kita haus, kita minum. Actually, kenapa kita haus? That is signal from our hypothalamus that the what you call it, your blood osmolarity is increased. Okay? Osmoreceptor in the hypothalamus monitoring the osmolarity of blood. So the increase of blood osmolarity, for example, beyond 295 milliosmol per liter of blood due to eating salty food, for example, or losing a lot of water when sweating, for example, or when you are fasting, for example, right? So it will increase the blood osmolarity. So the increase of blood osmolarity will triggers the release of ADH from posterior pituitary gland. Okay, right? And first, activating the thirst receptor, right? So physically, kita akan minum air, right? So this is one way to reduce blood osmolarity back to the set point. So bila kita minum, we are actually helping to reduce the blood osmolarity. Okay. At the same time, right? The release of ADH the ADH will travel in the bloodstream, and then it will reach to the target area or to the target organ or target tissue, which is the kidney. All right. Okay. So next. Okay. As for the kidney, ADH activate membrane receptor on the collecting duct, right, to increase aquaporin on the collecting duct. So it also make the distal tubule become more permeable towards water. So in other words, ADH cause the collecting duct and also distal tubule to become more permeable towards water. So more water will be reabsorbed from the distal tubule and also the collecting duct. So water will be reabsorbed. Reabsorbed tu maksudnya daripada mana ke mana? Daripada mana? From the filtrate ataupun from the distal tubule and collecting duct to the surrounding capillary ataupun to surrounding tissue. Okay, more water will be reabsorbed. Okay, so as a result, what happened to the remaining fluids remain behind, right? So it will produce concentrated urine as more water is reabsorbed. So urine become concentrated. Okay, right. So, and thus your blood will back, ataupun the blood osmolarity will reduce and back to the set point. Okay. Now, what if we drink a lot of water? Alright, duduk je dalam office biasa-biasa macam ni, tapi minum air banyak sangat. Right. What happened to us? Right. As we drink a lot of water, so the blood osmolarity will decrease due to the large water intake. So ADH secretion from the pituitary gland, posterior pituitary gland also will be decreased, and decreased permeability of distal tubule and collecting duct towards water, right? So reduce reabsorption of water, and then you are going to excrete or discharge large volume of diluted urine. That's why kita akan urinate frequently, right? Disebabkan oleh kita minum air banyak. Okay, so you can see hormone reflect or regulating the what we call it, reabsorption of water, right, in the kidney depending on the situation. Okay, so that's it for ADH regulation. Okay, now let's see renin-angiotensin-aldosterone system. So remember, it happens so related to the changes in terms of the blood pressure and also blood volume. So situation, what is the situation? Let's say you are in the mode of dehydration due to severe diarrhea, for example, all right? Or due to blood loss because of accident, injuries and whatnot. So blood pressure will drop, or you are going to lose a lot of blood volume, right? So this is where renin-angiotensin-aldosterone system will be activated. All right. Okay, so let's see here. Okay, renin-angiotensin-aldosterone system, or RAAS, respond to the drop of blood pressure and also blood volume without increasing osmolarity, right? Okay, so it happens so when you have this kind of situation, major wound or severe diarrhea or vomiting, for example. So it involves RAAS, involve juxtaglomerular apparatus, or we call as JGA, that is surrounding the afferent arteriole. So JGA supplies blood to the, the afferent arteriole is, remember, arteriole that supplies blood to the glomerulus. Okay, where is JGA? Look here. Okay, so this is JGA, juxtaglomerular apparatus, located, okay, at the afferent arteriole. Okay, right. So, okay, for example, so when there is drop of blood pressure at the afferent arteriole, it will be detected by JGA, juxtaglomerular apparatus, right? And thus, JGA will release enzyme renin here. Okay, you can see drop in the, what I call it, blood pressure or blood volume. Sensor in JGA detect the decrease in the pressure and also in the volume, and release renin. Okay, all right. Next, what happened? So enzyme renin will cleave into angiotensinogen. Sorry, renin cleave angiotensinogen to angiotensin 1. So renin is an enzyme, right? So what happened here? Oh, sorry. So this is renin. Renin is enzyme. So renin, right? Cleave, right? Cleave apa tadi? Tengok balik. Angiotensinogen to angiotensin 1. Cleave angiotensinogen. Here is angiotensinogen that came from liver, right, to angiotensin 1. Okay, right. Next. ACE catalyze conversion of angiotensin 1 to angiotensin 2. Okay. Angiotensin 2 triggers vasoconstriction of the blood vessel. So blood vessel become constrict, right? Increase blood pressure and decrease blood flow to capillaries in the kidney. Okay, right. Look here. Okay, so we have here renin cleave angiotensinogen to angiotensin 1 and ACE convert angiotensin 1 to angiotensin 2. So angiotensin 2 constrict the arteriole, so it constrict the afferent arteriole to increase the pressure, right? So it do also, what I call it, you can see over here, stimulating adrenal gland to secrete aldosterone. Okay, so what is the function of aldosterone from the adrenal gland? Okay, so angiotensin 2 also stimulate adrenal gland to release aldosterone. So aldosterone cause the distal tubule and collecting duct to be permeable towards sodium ion and also water. Thus, there will be more reabsorption of sodium ion and also water. So when there is reabsorption of sodium ion and water, it will increase blood volume and thus increasing blood pressure. Okay, all right. So why water is reabsorbed together with Na+? So remember, Na+ is a solute. So to maintain the osmolarity, right, or solid concentration, so water is reabsorbed together by osmosis. So this will help to increase the blood volume and also blood pressure, because when you are having diarrhea, you lost a lot of water, you lost a lot of sodium ion, right? So this mechanism, or RAAS, is actually help to increase the reabsorption of sodium ion and also water. Okay, right. Okay, so conclusion. So RAAS respond to the drop in the blood volume and also blood pressure by increased water and sodium ion reabsorption. Both ADH and RAAS increase reabsorption of water in the kidney. This is a similarity, right? However, whereas ADH alone would lower the blood Na+ concentration, blood sodium ion concentration via reabsorption of water in the kidney, RAAS help to maintain the body fluid osmolarity by normal range by stimulating the reabsorption of sodium ion. Okay, right. Okay, last part of this chapter is the function of liver. Okay, briefly describe function of liver. Okay, so this is the liver, right? So our liver is connected to the stomach, right? So it is connected to the gallbladder, right? The intestine, so which somehow helping us to understand the function of liver very well. Okay, right. Okay, so this is the detailed structure of liver. Okay, so you can see this is the gallbladder, right? So the gallbladder is connected here to the, very close to the pancreas. Okay, and then you can see over here, we have hepatic duct, right? Pancreas, a bile, okay, this one, bile duct, duodenum, okay, the stomach. Okay, now let's see here. So these are few functions of liver, right? The first one is liver help in metabolism of carbohydrate, right? Via 3 process. The first one is gluconeogenesis. So genesis means synthesis. Neo means new. All right, to build something new, right? So gluconeogenesis is a process to synthesis glucose from something else, like from amino acid, from lactate, or from glycerol. So in other words, glycerol can be converted into glucose, amino acid can be converted into glucose and whatnot via process of gluconeogenesis. Okay, number 2, glycogenolysis. Come from the word glycogen over here and lysis. So lysis means breakdown. Okay, so glycogenolysis is the breakdown of glycogen into glucose. Okay, assisted by glucagon, right? And next is glycogenesis. So genesis is synthesis or formation. So glycogenesis is the formation of glycogen from glucose, which assisted by insulin. Okay, that's number one. Liver helps in the metabolism of carbohydrate. Okay, number two, metabolism of protein. Okay, so liver carry out the process of deamination. D means removal, amination, amino group. So the removal of amino group, right? You can see it will form ammonia. So ammonia will be converted into urea during ornithine cycle or urea cycle in mammal. Okay, so urea will be leaving the liver and then maybe what you call it will be excrete out from the urine. Okay, next is byproduct of the deamination, it can form keto acid. All right, in the protein metabolism, right, as it carried out the process of deamination, it can form, instead of ammonia, it also can form keto acid. So keto acid will enter cellular respiration or converted into lipid. So this keto acid can enter cellular respiration in the form of alpha ketoglutarate. Right, keto. Okay, right. Next, the protein metabolism ataupun the process of deamination also can, in the protein metabolism also, right, it can carry out the process of transamination, where one amino acid can be used to synthesize another amino acid, those transamination. Okay, number three, liver helps in lipid metabolism, right, by converting excess carbohydrate to triglyceride when glycogen storage is full in the liver. So as we learned earlier, right, so glucose, excess of sugar, right, will be converted into glycogen by insulin, okay, and glycogen will be stored in the liver. But when your liver storage of glucose or carbohydrate is full, right, so the excess carbohydrate will be converted into triglyceride. Akan ditukar kepada lemak. Okay, a part of that, so in the lipid metabolism also, it can convert glycerol and fatty acid into compound that can be used in cellular respiration. For example, it can be converted into acetyl-CoA, for example, right? Or other compounds in the cellular respiration. Okay, or you can see here, fatty acid is converted into acetyl-CoA via process beta oxidation. Then it can be used as fuel in cellular respiration. Okay, and next, in lipid metabolism, so liver remove excess blood cholesterol and emulsified by bile. Okay, right. Good. Okay, number four, detoxification. Liver remove absorb toxic substances and make them harmless. The toxic substances, including alcohol, nicotine, that will be breakdown by chemical conversion within hepatocyte. What is hepatocyte? Hepatocyte is one of the cell ataupun component that can be found in the liver. Okay, I'll show you later what is hepatocyte. Okay. Next is it also helps to remove foreign material. Liver also help to detox or remove foreign material like by what call it? Remove foreign material by having Kupffer cell. So bacteria is ingested by Kupffer cell of the liver. Okay, right. So you can see this is Kupffer cell that will ingest bacteria, right? And this is the hepatocyte. Okay, right. Number five, function of liver is to break down and formation of red blood cell. So Kupffer cell, despite ingesting bacteria, Kupffer cell also help in breakdown red blood cell and resulting in hem, globin, and also iron. So for first trimester fetus, liver will be responsible for the formation of the red blood cell sebab masa ni dia punya bone marrow is not fully developed. So liver helps in the formation of the red blood cell. Okay, right. Number 6, function of liver is to produce bile. Right, so liver produce bile salt and form bile, hempedu. Kita panggil garam hempedu. And bile is salt inside the gallbladder. Okay, right. So again, this one showing you the Kupffer cell, right, and also hepatocyte. So this is the hepatocyte. Okay, right. And this is the Kupffer cell. Mana tu? This one, Kupffer cell. Okay, right. Number 7, so liver helps in the storage of minerals, vitamin, and also blood. Mineral like copper, iron, and zinc, right? That's why our liver is somehow like red because of presence of iron, right? And also heme, okay? And next is it also store vitamins like fat-soluble vitamin A, D, E, K, and water-soluble vitamins B and C. And it also helps in synthesizing plasma protein. So liver helps to form and store of blood in its blood vessels. So meaning to say liver helps in the synthesis of plasma protein and store it in the blood vessel within the liver. Okay. And example, globulin and clotting factors, which is fibrinogen, right? Right. Number 9, liver helps to break down insulin and other hormones. And by all means of the action of liver, as you can see, right? So the process induce or producing a lot of heat. So the heat production by the liver helps to maintain the body temperature, right? So the 10th function of liver is to produce heat, right? Okay, so these are the 10 functions of liver. Okay. All right, so again, homeostasis is maintaining, balancing everything, right? So how to maintain? So we have to have a balance, exercise, sleep, rest, okay, daily activities and whatnot, right? So to maintain or to get a very balanced life, okay? So that is mark our end of chapter 6, okay? Thank you very much. Assalamualaikum.